Hey guys, welcome to my channel. I'm Veda. In this video, I'm going to discuss solvent effect on nucleophilicity and Sn1Sn2 reaction. There are two types of solvent, polar protic and polar aprotic solvent. Polar protic solvent contains a hydrogen bonded to an oxygen or nitrogen. It is a hydrogen bond donor. It can solve both cations and anions. Polar aprotic solvents do not have acidic protons and therefore cannot hydrogen bond. Since aprotic solvents are acetonitrile, DMF, acetone, and DMSO, polar aprotic solvents solve cations only. Polar protic solvents have acidic hydrogens which can solve the nucleophile, reducing their nucleophilicity. In polar protic solvent, nucleophilicity strength will completely reverse because it is easier to break the ion dipole interactions between a weak base and the solvent than between a strong base and the solvent. The alkyl halide is the only reactant in the rate-determining step of an Sn1 reaction. It is a neutral molecule with a small dipole moment. The rate-determining transition state has a greater charge because as the carbon-hydrogen bond breaks, the carbon becomes more positive and the hydrogen becomes more negative. Since the charge on the transition state is greater than the charge on the reactant, increasing the polarity of the solvent will increase the rate of the Sn1 reaction. If, however, the compound undergoing Sn1 reaction is charged, increasing the polarity of the solvent will decrease the rate of the reaction, because the more polar solvent will stabilize the full charge on the reactant to a greater extent than it will stabilize the dispersed charge on the transition state. Most Sn2 reactions of alkyl halides involve a neutral alkyl halide and a charged nucleophile. Increasing the polarity of a solvent will have a strong stabilizing effect on the negatively charged nucleophile. The transition state also has a negative charge, but the charge is dispersed over two atoms. Consequently, the interaction between the solvent and the transition state are not as strong as the interactions between the solvent and the fully charged nucleophile. Therefore, a polar solvent stabilizes the nucleophile more than it stabilizes the transition state, so increasing the polarity of the solvent will decrease the rate of the reaction. If, however, the Sn2 reaction involves an alkyl halide and neutral nucleophile, the charge on the transition state will be larger than the charge on the neutral reactants. So increasing the polarity of the solvent will increase the rate of the substitution reaction. Aprotic polar solvents solve with negative charges particularly poorly. Thus, the rate of an Sn2 reaction involving a negatively charged nucleophile will be greater in an aprotic polar solvent than in a protic polar solvent. Consequently, an aprotic polar solvent is the solvent of choice for an Sn2 reaction in which the nucleophile is negatively charged, whereas a protic polar solvent is used if the nucleophile is a neutral molecule. But the solvent effect is the least factor that you want to consider when you determine which reaction type will occur. You can try to use this flowchart when you try to determine which reaction type will occur and which one will be dominant. In the next video, I will discuss Sn1, Sn2, E1, E2 reactions. So stay tuned.